We continue learning workbook page 116 with this final problem from this learning objective. This is the longest of the three problems. All right, we've got the square root of y plus 5 equals 1 minus the square root of y minus 1. Remember the steps. Step 1, isolate. Step 2, raise. Step 3, if there is no longer a radical in your equation, solve and then check. But if there is still a radical in your equation, you need to go back and repeat steps 1 and 2. In this problem, we're going to see that we will have to go back and repeat steps 1 and 2. Let's begin. All right, so we need to pick a radical to isolate. We have two to choose from, this one and this one. So the first thing you should ask yourself is this: is one of those radicals already isolated? And the answer is yes, this one. There is no adding, subtracting, or dividing before, after it, or under it. So step 1 is already done for us. This radical is isolated. So we move on to step 2. Step 2 says, whatever is the index of the isolated radical, raise both sides to that power. Now, how many sides does an equation have? 2. So when you go ahead and write your exponent of 2, you can only write parentheses with an exponent, parentheses with an exponent twice, because an equation has 2 sides. If you ever find yourself writing more than 2 exponents, you are making a mistake. Stop what you are doing. Okay, so now we're going to simplify this. The square and the square root cancel, leaving me y plus 5. And over here, an exponent tells me how many times to multiply a base by itself. So this is 1 minus the square root of y minus 1 times another 1 minus the square root of y minus 1. And we have to FOIL here. All right, so let's go ahead and FOIL. What we're about to do is very similar to what we did in section 7.5 when we were rationalizing denominators that happen to contain 2 terms. So we're going to have 4 products, and in between each we're going to have either an add or a subtract sign. All right, here we go. So the first product is 1 times 1. That's a pretty easy one. The second product is 1 times this radical. And because we have a positive times a negative, we write subtract. The third product is going to be this radical times 1. And because we have a negative times a positive, we will subtract. And the fourth product is this radical times this radical. And because we have a negative times a negative, we'll write plus. All right, take a moment here and look carefully. Product, 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 product. And in between, we have adding and subtracting signs. Make sure your work looks like that. Okay, now we're going to start the simplifying process. 1 times 1 is 1. Anything times 1 is itself. Anything times 1 is itself. And this is a radical times itself. So that's the same thing as the square root of y minus 1 squared. Okay, let's continue solving. We're going to bring our work to the top of the page here. So we have y plus 5 equals 1. Now the first thing we want to do to create a simplifying process is right here. And we have to be very careful. So when you have minus radical, and the radicals are exactly the same, then the result will be minus 2 of that radical. Minus 2 of that radical. Now on the off chance that you find that difficult to understand, let's look at a similar comparison involving a simpler concept. What happens if you have negative x subtract x? Well, that makes negative 2x. What happens if you have minus root 3 minus another root 3? Well, that's the same thing as minus 1 root 3 minus 1 root 3, so we get minus 2 root 3. We can use the same concept to combine these together. This is like minus 1 root y minus 1 minus another 1 root y minus 1, so the result is minus 2 root y minus 1. All right, Over here, we've got a square and a square root. Those cancel. So I'm left with plus y minus 1. All right, let's continue simplifying. Y plus 5 equals. On the right-hand side of the equation, I have a positive 1 and then a subtract 1. So those are going to cancel to 0. So then I have this y and then subtract 2 square root of y subtract 1. Now, you might be thinking to yourselves, where are we going with this? What's the objective? Well, we've done steps 1 and 2, which is to isolate and raise, but we still have a radical in our equation. So now we have to go back and isolate and raise again. We need to make sure that this radical right here has no adding, subtracting, or dividing before it, after it, or under it, which means we need to get rid of this y. So we're going to subtract y on both sides, and then we're going to have the result 5 equals negative 2 square root of y subtract 1. All right, so now our radical is isolated. This is not subtraction, that's a negative. The rule says if you want to isolate, there has to be no adding, subtracting, or dividing before, after, or under your radical. And we don't have any of that. We have multiplying, so we are isolated. All right, so once you isolate, the next step is to raise. Take the index of your isolated radical, which in this case is a 2, it's a square root, and then raise both sides to that power. So parentheses with an exponent, parentheses with an exponent. Remember, an equation only has 2 sides, so you can only write parentheses and exponent twice. 5 squared is 25, and an exponent tells me how many times to multiply a base by itself. So this will be negative 2 times the square root of y minus 1 times negative 2 times the square root of y minus 1. Putting the outside stuff together, negative 2 times negative 2 is 4. And then a radical times itself can be written as that radical squared. So now we have 25 equals 4. The square and the square root cancel, leaving me y minus 1. And the y minus 1 must be put in parentheses. Okay, so now, finally, we don't have a radical anymore, and we can proceed with the rest of the steps, which is to solve and check. Let's distribute the 4. So 25 equals 4y minus 4. Add 4 on both sides. We get the answer 29 equals 4y. Divide by 4 on both sides. And we get y equals 29/4. Now, is this our final answer? Maybe. Remember, you have to do all 4 steps, and the final step is to check. So go back to your original problem and replace all of the variables with 29/4 and simplify both sides and see if the left side and the right side match each other. Okay, the original problem we started with was this. Square root of y plus 5 equals 1 minus square root of y minus 1. Okay, let's plug in. So we get square root of 29/4 plus 5 equals 1 minus square root of 29/4 minus 1. Okay, now we cannot add a fraction and a whole number. We cannot subtract a fraction and a whole number. So the only way we can proceed here is to turn our whole number into a fraction. 5 is the same as 5 over 1. One is the same as 1 over 1. And then get a common denominator. So the denominators here are 1 and 4. We want them both to be 4. So we multiply top and bottom by 4 here and here. This gives us the square root of 29/4 plus 20/4 equals 1 minus the square root of 29/4 minus 4/4. once you have a common denominator, you can add or subtract your fractions. So this is the square root of 49 fourths equals 1 minus the square root of 25 fourths. Remember your quotient rule for radicals from earlier in this chapter. A radical of a fraction can be written so that the numerator gets its own radical and the denominator gets its own radical. So we'll write our response like this. Now take all of your square roots. The square root of 49 is 7. The square root of 4 is 2. The square root of 25 is 5. So we get 7 equals 1 minus 5 halves. All right, I need to combine this whole number in this fraction. I'll use the same method that I did before. I'll write 1 as 1 over 1 and get a common denominator, which will be 2. So then I get the statement 7 halves equals 2 halves minus 5 halves. And when I subtract these, 2 halves minus 5 halves equals negative 3 halves. And that don't match. Which means my solution, 29 fourths, is extraneous. And since it was my only possible solution, we conclude that the answer to this question is there is no solution.